Good morning, good afternoon, good evening, everyone. Thanks for joining this talk about a journey with SLE BCI from creation to adoption. My name is Marco Varlese, and I'm here with Frederic Crozat to talk to you about SLE BCI. With that, so what's the agenda? The agenda that we will present to you is the vision, the ideas, and the strategy surrounding the production of SLE BCI. How do we build SLE BCI? So some technical details on the processes and on the tools and how we actually or actually how we went from the idea to making this a reality. Then we also talk to you about some quality assurance points. So how SLE BCI is being tested, validated, hardened, and make sure that it's secure. And then last but not least, a demo. With that, my name is Marco Varlese. I work from Italy and I'm a director of engineering here at SUSE, working on the systems engineering department. And I have here with me Frederic Crozat. Frederic, please introduce yourself.
Thank you, Marco. So my name is Frederic Crozat. I'm working from France, and I'm architect for both Linux containers, which includes SLE BCI, and also our upcoming platform, ALP.
Thank you, Frederic. Obviously, the team for SLE BCI wasn't just myself and Frederic, but we had Michael Schwetz, who's the product manager for SLE BCI, Dirk Müller, Olaf Kirsch, Matt Farina, and Markus Meissner, who are distinguished engineers helping with their expertise, making SLE BCI a success. Then we have Bruno Leon, Jose Lausic, Dan Cermak, Fabian Vogt, Herman Jimenez, Vincent Mutasami, Alexander Herzing, myself, and Frederic, who have been part of this whole team. With that said, what is SLE BCI and what's the vision behind it? The vision or the idea that basically made this group of people start working on SLE BCI was to create a flexible developer experience that provides and integrates with and supports language native uh, tools and libraries, workflows, by offering a self-contained environment which is targeted to a specific version of any programming language's ecosystem. When it comes down to that, it's not just about software development, but it's also about testing, validation, and eventually deployment. So, if you wish, the whole DevOps life cycle. And I will show you what languages and ecosystem we currently support. We had a very short demand and deliverable in mind. The basically offering a developer-focused repository, so that basically container application developers could pull down language packages as needed and very easily to create their applications. The container image must be freely redistributable, and the repository available without a subscription. Why? Because most of our end users will have to basically redistribute their container images, their derived container images, to basically offer their application to their customers. And in that regards, we had three main use cases in mind: Rancher, cloud native developers, and ISV, IHV developers. Rancher, the first one was actually the first one to take SLE BCI and use it for Rancher 2.6 back in June 2021. What we currently offer, the state of the art for SLE BCI, is a repository which is available by default on every single SLE BCI image. And today that contains more than 7,000 packages. We have a permissive EULA enabling the redistribution of all images that are defined as SLE BCI images. We obviously offer a guaranteed FIPS compliance when using SLE BCI images with a paid subscription. What does this mean is, if you're interested in just ensuring that SLE BCI runs on a FIPS-enabled host, then I can tell you it will work. However, if you are willing to basically claim compliance for FIPS certification, then you will need a paid subscription with SUSE. With that, we have a wide variety of images and portfolio. So, for example, if you have the chance to reach on registry SUSE.com, you'll see that there are plenty of different images and they are organized in different fashions. So the first organization is about OS level container images, and they are basically the base image, the minimal micro init images. There are differences across all of those, and there are different use cases that we thought about when creating those images. For example, both minimal and micro, they come without Zipper, our package management system. However, minimal is actually still offering to the end user RPM executable to provide a way to install prepackaged software. This is, for example, very interesting option for those ISVs, which so far have been really uh, very close with our technology and already familiar with RPM as a technology, because they can still be building packages and RPMs, and having RPM as an executable helps them tremendously. The case for PCI Micro instead, not even having RPM, is mostly targeted to, for example, cloud native developers writing Go application. In that case, most of the artifacts will be basically built and just copied onto the final image, which could be exactly BCI Micro. So for each of these use cases, there are specific images that are made available from a registry perspective. With that, there's also a long list of programming languages container images. And right now we offer .NET, Java, Python, Ruby, Node.js, Go, and Rust images. For each of these, obviously we have different versions being offered. For example, for .NET, we offer version 3, 5, and 6. And for Go, we follow what the upstream latest and greatest is, together with keeping and offering the last two ones exactly as the upstream folks do in the Go environment. We offer OpenJDK, and sooner there should be also an OpenJDK and runtime for 17. So all this is really a work in progress, an evolution, and it's an evolving environment. So all I can ask you is please get onto registry.suse.com, keep it, bookmark it, and see what's coming next in the next months. With that, I would really love to pass the words to Frederic, who's going to talk to us about some of the details surrounding SLE BCI. Frederic, please.
Thank you, Marco. So this is a technical session, so you are probably interested on how we build SLE BCI, why is it interesting for you to use SLE BCI compared to picking a random container on the Docker. So Marco already said it. When we speak about SLE BCI, we talk about two things. Both a catalog of containers. Marco already listed most of them, and there will be more containers coming over time. And also a freely available package repository, because some of the containers are base container where you want to put more application, more packages, and to do that, you need packages which are signed by SUSE. So we have a set of rules to build our BCI containers. Those rules are quite simple. All the packages used to create the SLE BCI containers must be SLE packages. There is absolutely no exception. What does it mean? It means you get all the check, all the support in terms of code review, in terms of security fixes that you get from a regular SLE subscription. You get all of that in the SLE BCI containers, thanks to those packages. Those packages are signed by SUSE. They are binary identical to the SLE packages. So this is the rules to create the containers, as Marco mentioned, the various base containers and all the language stack containers. And we also have a set of rules for the SLE BCI repository, which contain, I think, more than 4,000 packages. My numbers might be a bit old, but we have decided to put a subset of the entire SLES packages in this repo because we target those packages to be for containers, which means we don't put kernel in this SLE BCI repo. We don't put bootloaders. We don't put hypervisor because obviously you are running containers. You are not running an hypervisor, nor, for instance, desktop-related packages. Those packages are not available in the SLE BCI repository. They are only available if you have a SLE subscription. All those packages, again, in this SLE BCI repository are always available with a regular SLES subscription, be it through the customer center, through SMT or AMT. Which means if in the event you need some packages which are not available in a SLE BCI repo, but you have a SLES subscription, you can very easily inherit your SLES subscription when building containers based on BCI and get those packages and put those packages in your own containers. As I already mentioned it, all the packages shipped in the BCI repository are binary packages which are identical to the SLE packages. We don't make any changes. If there are changes, it means they have been going through the regular SLE process. And sometimes we have, during the course of developing SLE BCI, we have fixed bugs which were very specific to BCI, but they are been made also available to our regular SLES customer. Also, a small difference between a regular SLES subscription repos and the SLE BCI repo. Only the latest version of each package is available there, which means when there is a maintenance update of a package, the previous version of the package are not available anymore in the SLE BCI repo. Only the latest version is. If you need to pin to a specific version of a package, then you need a SLE subscription. So I talked about what we put in the containers. So how we build those containers. Since it's a process which has been evolving at SUSE, initially we created all the BCI containers for SLE 15 SP3 as using Kiwi, our technology, and Kiwi files. So those containers, you can check the sources on the build service, on the open build service. Initially, we used Kiwi, but with SLE 15 SP4, which will be released really soon, and it might even be released by the time you see this recording, we migrated those container definition from Kiwi files to Docker files, maybe with a few exceptions where we could not build some containers with Docker files, simply because it's what people are mostly used to, and if they want to review our sources, it's easier for them to look at Docker file. Those Docker files are generated with a template engine, so which means we can very easily update those containers. As I said, all the sources of the containers are visible on the open build service, and now, for a few weeks now, even the next version, so the development of the BCI containers, is also visible on the Open Build service in the devel column BCI project. If you check there, you will see there are various projects per service pack. All those containers are rebuilt automatically when there are maintenance updates released, and then the containers are released if they pass successfully our QA testing pipeline. I talked about how we build those containers. What is important also is security. What is happening when we create those containers? So when there is, as I said, a maintenance update, which can be a security update, packages are released to the regular SLE channels and the various products. And internally, in our build service, we have automatically containers which are rebuilt with the latest version. So you don't get all the, you get, sorry, all the security fixes. And then they goes automatically in our QA testing pipeline. And everything is green, so which means we know that those containers are not going to cause regression. They will be released automatically. So usually it should be the same day the maintenance update is released as packages. It might be a bit slower sometimes, but usually that's what we target. So a bit of tooling of machinery on how we build things. As I said, all our containers definition are stored, are generated with a template engine. So this is running, our definition are stored in a GitLab repo, which is internal to SUSE. Then everything is built in our build service, the internal version of the build service, so internal to SUSE. We have a set of staging repo. We check that everything pass both building, and all the tests. All tests are run thanks to OpenQA, which you might be already familiar. It's already also used to test the entire SLE distribution and the various OpenSUSE distribution. And we have even other friendly distribution which are using OpenQA these days. And if, again, QA pipeline are green, then it will be released automatically to registry SUSE.com. Talking again about security, you might be wondering, how do I know if my containers, the container I use from BCI, are vulnerable to some CVEs? So we have several ways to notify you. We send updates by email to mailing lists, so SLE updates, which is all the maintenance updates which are released, and SLE security updates, which are just the CVE-related updates. We have also, of course, our webpage on the SUSE.com website, the CVE page. Now it has been improved so that you can see which version of each container is vulnerable and which version is fixed. So this way you can know if you need to rebuild your own container based on our BCI containers. So just small screen capture of the website for one CV which was affecting glibc some last year, 2021. So as you can see, you can check which container. So if you were using, for instance, a Node.js container, the latest version was fixed. Obviously, if you are using the SLE 15 container, which is now also called PCI base container, you would have to pick 15.3.17.8.9. Sorry for the long list of numbers. Or later to get to get sure your container has the fixed in it. And for better overview of what's going next, Sometimes there are CV which are public, but the fix is not yet available, so it's in the process of being built and validated internally. So you get also those information on the website. For instance, when the screenshot was taken, there was a CV affecting the Ruby container. So it was, you could expect it to be fixed soon. And the Node.js, there was a security fix which was already being worked on internally, but not yet released. Also, regarding still security, important is we export all our security data under various format, under the overall data format, which is XML text, which specify which version of each RPM fix which CVE. The CVE are of data, which is the XML version of the advisories, both per advisory or per CVE. And talking about container more specifically, you can check with various container scanners if a container is vulnerable or not to some CVEs. We have been working with Trivy upstream to make sure that they are able to parse the RPM database, which is part of each BCI container. So this is something very important. Even the smallest containers that we ship, we always keep the RPM database as part of the container so that you can check which package, which version of each package is part of the container. And this is used by the various container scanner, such as Trivy, such as Tenable Nessus, to see if a container contains vulnerability or not. Of course, NeuVector, our newly acquired company, will provide also support for BCI containers. This is work in progress. We are working with our new colleagues, and the target is Q2 this calendar year for that. And also there is a Synopsys Black Duck binary analysis, which is available to scan containers. Talking about security, let's talk about signing, because it's nice to get containers. It's even better to be sure that they have not been tampered in between. So all our registry SUSE.com and the build service supports various ways of signing containers. Notary version 1 signing. Also the Red Hat style Podman signing. And recently we have been working on signing with the cosign from Sixtor, which is now available and enabled. So it's available as part of the build service, and it's enabled for BCI containers. We are rolling this over time on all the containers because it has a lot of metadata. So don't be frightened if you look at the metadata of the BCI containers. If you see a large blob of, I think it's, I don't remember which keys are used, but if it's RSA or something like that, don't be frightened. It's normal. So again, we use cosign with Notary v2, and the container keys is always shipped as part of the SUSE build key packages. A small word about quality assurance. I've repeated it several times. We have QA automation because obviously we don't want to spend time and on manually testing containers. This is not something which can be done quickly enough. So we ensure we have enterprise quality in our SUSE deliverables. The speed, as I said, is key in the container world. And we automate. As part of our test matrix, we test our BCI containers on a lot of environment and not just SUSE environments. So obviously we test BCI container on SLE 12 SP5, which was only shipping Docker. We test on SLE 15, being GA SP1, SP2, SP3, the soon to be released SP4, both using Docker and Podman as container runtime. We test also on the OpenSUSE Leap distribution 15.2, 15.3, and soon 15.4. And we test also on other distributions such as CentOS using Podman, Ubuntu using Docker and Podman, RHEL using Podman also, and on some various public cloud Kubernetes engine, such as Amazon Kubernetes engine, which is using Containerd, Azure, and there will be more to come. And with that, I hand over the microphone back to Marco. I've been talking way too much, and he's going to demo us BCI containers.
Thank you very much, Frederic, for all the details that you have provided. It's a true journey. So, as Frederic said, I will showcase a demo, and before doing the demo itself, I would basically drive you through some of the changes that I apply to the Docker file to make it working with SleepBCI. First thing first, the project that I picked, it's called Distribution, is an upstream project living on GitHub, and basically it offers a registry. So since we are talking about containers are made available to the end users via registries. I thought it was a nice thing, also quite circle to use a container to build the project, which then gets containerized in a container, which eventually, when running, offers containers. It's quite funny. So on the left-hand side, there's the Docker file as it is from the GitHub project. And on the right-hand side, I have my new file, which is using BCI, SLE BCI. And I would like to basically show how easy it is to port a project using any given base container image onto SLE BCI. So in this case, for example, here, this project was using the Alpine base image for Go, specifically the Golang column 117-Alpine as base image, which was being used to build this project. On the right-hand side, instead, we have our new Docker file, which is using the registry susecom BCI Golang image, version 117. As said, we have different versions offered, but we do indeed have 117. And this is again being used as the base image to build the project itself. Then, what else? Well, there are some changes required due to the different package management tool that we have on SLE or on all SUSE product, also like OpenSUSE Leap uses Zipper, differently from what Alpine offers, which is APK. So in this regards, it's a matter of changing the command line which runs APK on to making it using Zipper. And yes, just pass a small tiny parameters to make it working non-interactively. Obviously, this is a container that gets built through the Docker build command. So we cannot interact to say yes or no to certain questions that Zipper may ask. And then, as you could see, then the package names are pretty much the same. Bear in mind, I have here git-core, and this was intentionally done to make the package installed on the container a smaller footprint. Just installing Git brings in other dependencies which are not really required in this case. And so by picking git-core, I also ensure to have a smaller footprint of not really required packages. Otherwise, these packages are pretty much the same. Last but not least, this Docker file is a multi-stage build. So the first base image is being used to build the project, and then there is a last step when a different image is used to deploy the compiled artifacts. As you could see, though, the remaining of the Docker file where all these actions are taken stays the same. And then we change again just the last bit where rather than using the Alpine column 315 base image, we are actually using our BCI micro image. Again, very easy, very straightforward, no other changes required. This is for the Dockerfile differences. Now let's see the demo in action. On the left-hand side here on my terminal, I have basically created two scripts just to make this thing easier to showcase. On the left-hand side, I'm going to build the project. On the right-hand side, I will be running the project. So first of all, let's build the container with the distribution project itself. Oh, and I should really run Docker first. Okay, so there you go. Sorry. So what's happening now is the Docker build using the Docker file BCI is going through the build steps, right? And some of this is using Go releaser, so it's taking all the dependencies that are required to build the Go project. We are now downloading the Golang image from registry SUSE.com, uh, which takes a little bit of time. It's a decent size image, so let's wait for the download to be complete. Uh, the BCI micro image has already been downloaded at stage dash 5, 1 of 3. So let's wait a few more seconds. This should be really done in no time. Okay, so now it's extracting the image. It is done. Now it's building the project with all the dependencies. Just a few more seconds, and we are done. So it built, and now the container has also been bootstrapped, so it's running. This is basically the distribution project running. Basically, the registry is now fully deployed onto my local machine, which basically can serve request of pull push of container. To run these projects, well, we need to obviously map some ports because it listens onto ports for interacting with the external world, basically being Docker pull, Docker push, and so the port 5000 of my local machine is being mapped onto this container. Now let's run the demo. Let's see. So what I'm gonna do first, I'll pull from the registry SUSE.com SLE BCI micro image, which is the one that I want to basically push onto my own local registry. So I pull it, and then I have to retag this image to make it possible to be pushed to the local registry. This is just a normal step, a procedural step that needs to happen. So I've done that, and then I obviously show you that I have both the BCI micro image from the registry that I pulled earlier and the new one which I retagged with localhost tagging. So now I'm pushing this libci micro image to my newly deployed registry, which runs on the left-hand side. And if you had a chance to look on the left-hand side of the screen, you may have seen a lot of new messages being printed out, basically all these debug messages. And it's the registry who has received a push request from the other command from the other terminal to basically deploy a new container onto the registry itself. So this step is done. Now the registry holds a BCI-micro image which we had previously pulled from registry SUSE.com. Now it's also deployed onto localhost colon 5000. And last but not least, I just removed this BCI macro from my local cache, not from the registry, but from my local cache, and I can now repull the image from the registry which runs locally. And if you have seen on the left-hand side, a new request has also been displayed in the debug messages. That was the pull request that I ran here to take BCI micro from localhost colon 5000. And eventually, what I end up with is again having a BCI-micro onto my local cache. So again, this was all done on BCI images using a Golang image. So an image specific language to build this project and a more slim OS oriented image to deploy the artifacts of this project and eventually run this container image in a production environment. And with that, it's really all. This is the demo, and I would like to thank everyone for being here with us today and for listening to us. And I hope you found this talk informative and interesting. And if you have any questions, please do not hesitate to reach out to me or to Frederic. We are here and we work at SUSE, so you can always reach out to us, our company mail address, and we will be very, very happy to assist you with any questions that you may have. Frederic, you want to say anything?
I think you said it all. Again, thank you for listening to our talk. We hope you will try SLE BCI soon, and you will uh, be surprised, but in the good way, with all the nice things we have done there. And it will bring better support, better enterprise stability to containers, which is exactly what we are reaching with SLE. And with that, I would like to thank you for attending this talk. Have a great SUSECon.